Welcome back to my part 2 of the Stock Pot 2 refining series here. What we're going to do here is try to get the material that we incinerated. I'm going to try to grind it up in this mortar and pestle here and see if we can get it through a fine mesh screen and into this beaker. I'm just going to put a little bit of it at a time into this mortar and pestle, grind it up, and then run it through the screen. Here we go. Let's see what happens here. It's nice and dry. It's going to be nice and powdered. I think this is going to work out okay. Continue doing this until I have all these solids ground up and through the strainer and into my beaker here. It's going to take a while. I've been working at it now for about 5 minutes or so, I guess. So what I'm going to do, the time is 11:20. I'm going to turn the camera off. I'm going to grind the rest of this up, get it through the strainer. When I get that done, we'll come back. About halfway done here. I've only been working on it for about 10 minutes, but I wanted to show how this material is glued to this melt dish. I gotta watch it, trying to pry it off the bottom of the melt dish there. It's kind of really stuck pretty good. Just wanted to show that. We're making some good progress here, so I'm going to continue this off camera now, and when I get completed, we'll come back when we got all this stuff ground up, pulverized, and in a finely divided state in my beaker. Time is about 3 minutes to 12. I think I started at 20 after 11. So it took me about 40 minutes to get all of this material through the strainer. And I've got it all now in a finely powdered state. What we're going to do is I've written the weight on the side of the beaker. So we'll take this in now and weigh it up and record the weight of the material inside the beaker. I weighed the beaker before we started. It's 491.1. We'll put this up here on the scale. We've got 842.3. So we take 842.3 minus 491.1 equals, we've got 351.2 grams of material in our beaker. I left the lid on the beaker by mistake, so I need to subtract that from the amount of material that I calculated earlier. So I got to take 214.7 from the 351.2 grams that I got earlier, and you'll see that I've got 136.5 grams of material in the beaker. 350 milliliters of distilled water. Now I'm going to add about 150 milliliters. Now let's make it 100 milliliters of nitric acid here, going into the distilled water. And then we're going to add that mixture to our material here. We're going to put it up on the heat, and we're going to let this heat up and see if we can draw off some of the copper that might be in here and some of the palladium that might be in here. Just going to let this heat up on our stove, our burner back here. On. Set this up on the heat now. We'll let this cook and go from there. This is time lapse. About 5 minutes into the reaction, you'll see here coming up, we have a runaway nitric reaction, delayed nitric reaction right there. Luckily, I had it in a tall beaker, so that nothing spilled out and over the top of the beaker. But that just goes to show you, when working with these platinum group metals and the nitric acid, you can experience a delayed runaway reaction that happens when you're not looking, you're not expecting it, and just 5 minutes after the reaction starts, you get a big reaction like that. And if you're not careful, you'll have a boil over. Add about 100 milliliters of nitric acid here, and we're going to look and see what kind of reaction we get when we add the acid. We get a whole bunch of fumes. That means we still got a bunch of stuff here that's soluble in nitric. If we get very little reaction, that means just about everything that's going to dissolve has dissolved. This is probably about 75 milliliters, not 100. Concentrated nitric acid going in real slow here. Oh, there we go. Alright, that gives us a good reaction there. A little bit more. Gotta watch adding this to this, these solids. Could cause a runaway reaction. So we want to add this real slow. So definitely, we still got stuff going in solution here. We'll add the rest of this acid real slow. Those acid fumes are clearing up rather quickly. I'm going to put a little bit of distilled water in here. Probably about 100 milliliters of distilled water. Now we're going to add a little bit more of this nitric acid. The solution is still going to be real hot, so I'm going to watch how I add this. Still reacting pretty good with the nitric. Alright, I'm going to try to get the rest of this nitric acid in there. There's probably about 50 milliliters left to go in. And put that water in there to rehydrate it. Make sure that the dissolved metals some place to go. When the nitric acid puts them in solution, the nitric acid will dissolve palladium and copper out of this, out of these solids. But boiling acid boiling nitric acid. We'll also put a little bit of gold in solution, as well as some of the other platinum group metals. Let's get a little bit more of this in. Once we get all this in, I'm going to let it sit on here and react all that it will. What I want to watch out for is a delayed runaway reaction from adding too much nitric. Sometimes when you put the nitric acid in there, it will react calmly like it is right here, and then all of a sudden just start riding up the beaker and spill out. So you got to watch out. Pour this nitric acid in real slow. It's 5 minutes past 1. I think we've had this on here on the heat now for about 45 minutes. I'm going to try to add the rest of that 100 milliliter dose of nitric that I measured out earlier. It was actually just a little under 100 milliliters. Still getting a pretty vigorous reaction when we put it in. Of course, that solution's boiling, so it's gonna react like that. Not a whole lot of fume production though, a little bit, but not a whole lot. So what I'm looking for here is whether or not we got the metals that will dissolve in the nitric dissolved out of our solids here. Looking for palladium, copper, mostly palladium and copper, to be dissolved out here. And the solids that get left behind should be gold and other platinum group metals. Let this cook. Like I said, the time now is about 6 minutes past 1 o'clock. I'm going to let this boil away for about an hour here and see if we can get everything that will go into solution with the nitric dissolved out of our solids. About 7 minutes to 2. So we've been on boiling now for about 50 minutes. What I'm going to do here is put a small splash of nitric in the beaker. I'm going to add it to this, see what kind of reaction we get here. Not really a whole lot of reaction going on there with fresh nitric additions. I think we pretty much got everything dissolved in here that we want to. I'm going to take this down now. Take this off the heat. We're going to add some distilled water to it and just let it cool off. Then we're going to do some tests on the liquid here, see exactly what it is that we have in solution. I'm expecting that we'll probably have some, we're going to have copper in there probably, and I'm expecting a little bit of palladium in here. So I'm just going to pour some distilled water in to cool this off. And then I'm going to let it settle, and we'll take a look at it and see what we got. Time right now is 5 minutes before 2. We'll let this settle. We'll come back out and look at it here in a few minutes. I've got a funnel set up here with one of my specially prepared filters. Now what we're going to do is we're going to siphon all of the liquid that's settled and cooled. We're going to siphon the liquid out of here through the filter and get it down in this flask. While I'm waiting for this to pull through the filter, I'm going to add some distilled water to the solids in the beaker here. You can see it's about 1/4 of an inch of mud down on the bottom. I'm going to rinse this off now with some distilled water. Got everything pulled through the filter. Got some rinse water in here on our solids. Pull the flask up, and I'm going to pour the rest of the solids into the flask. Capture the solids in our filter here. Looking pretty good. I've got all the solids up here in this funnel. I'm getting all the green liquid rinsed off of this. We're going to collect that down below in our flask down here. If you look at the water, that water is running clear. What I should have now is a fairly decent separation. I should have my palladium, possibly some copper down here. And up here I should have my gold and some platinum group metals in those solids. Alrighty, here we go. I'm kind of making this up as I go. This is a rinsed beaker. Should have some platinum group metals and gold in these solids. Although there will probably be a little bit of palladium in here as well. So we're going to add these solids to this beaker over here that I've rinsed out. Notice how clean the funnel is. That's the point of putting that special filter in there. And this here should be my palladium and any copper that was in there, the solids. But there will probably be some gold and other platinum group metals in here as well. Just like some of the palladium and copper will still be in the solids, you can never get a 100% separation with these platinum group metals. Alright, we're going to work with this now. We're going to try to dissolve these solids in hot aqua regia. Adding some hydrochloric acid here. That's about 250 milliliters. Now I'm going to add some concentrated nitric acid to it. And we're going to form some aqua regia in here. start trying to dissolve these solids on some heat. All right, that was about 15 milliliters of nitric acid. I'm going to stir it up. And we're going to put it up here on the heat and start dissolving the platinum group metals and the gold. Here we go. I'll move this out of the way. This has been on now for about 15 minutes. I'm adding another 200 milliliters of hydrochloric acid. And then I'm going to add some more squirts of nitric acid. We'll let this continue to react, try to get all those solids to go in solution. That's another 9 milliliters. So I got 24 in there now. Let's put it out here. Almost had a boil over. Gonna watch how we add that nitric acid. Alright, I think you can put it back up on the heat now. It's finally divided, so it's gonna react like that. Well, that was a close one. But at least I was prepared. I knew what to do to get it off the heat, get it into a catch container. All right, while we're waiting for that to dissolve, what I'm going to do is I've got our palladium solution here. I'm going to transfer our palladium solution into this tall beaker here. We'll take a look and see what we got in this solution. No sediment at the bottom, that's good. Means our filtration was good. I'm going to dip a piece of filter paper in our solution here and get a stannous test on it. Got it's like platinum group metals in solution. It's what we want to see. We'll draw out a little bit of solution, put it in this small beaker, and then I've got a solution of dimethylgloxine over here. What we'll do, get a little bit of DMG, dimethylgloxine, in the pipette here. And now I'm going to add it to this beaker. See what kind of reaction we get here. If there's palladium in solution, we'll see a bright yellow precipitate form. Let it react. Here's our DMG test. The DMG precipitated out the palladium. So now what we're going to do is show you how effective that was. Here is the original solution. status test on it. See how dark that is? And then after we add the DMG to it, a little bit on the edge here. You can see I barely got any kind of reading on it at all compared to the other test. So the DMG is effective at dropping palladium out of our solution. Okay, now what we're going to do is set up the stir plate. We're going to mix up a batch of dimethylbloxine. Got a stir bar in there, and that's distilled water to this. And dimethylbloxine does not dissolve very well in water, but we'll get enough of it to go into solution for what we want to do here. I'm going to turn the stir bar on, get that thing stirring, get some heat going. Now we're going to dissolve some of our DMG in hot water. We're going to add it to this solution and precipitate out the palladium like we did in this sample. That status test indicated a fairly low concentration of palladium, and I'm just kind of flying by the seat of my pants here, trying to determine how much DMG to add to that solution. My DMG to dissolve, I'm going to add another shot of nitric acid to our solution back here. I'm going to do it slow this time. Reacts pretty good. Fume production inside the beaker is pretty low there, so I'm figuring that most of the solids that are going to go into solution with that aqua regia have dissolved. Let's stick a piece of filter paper down in here and get a little bit of this solution on here. And we're going to give this a status test right quick. See what we got going on in there. Oh yeah, we got a real dark stain. We've got gold and platinum group metals in solution. Now what we'll do, I'm going to turn this off, rinse the sides down, let this cool off and settle out, and we're going to get some of that solution off any solids that might be left in there. Now what we'll do is turn our attention over here to the DMG, turning the heat off, and what we'll do is take this off the heat. Put our solution up here on the stir plate, and now what we'll do is add the DMG, stir bar and all, to this solution to get our palladium precipitated out like we got in our sample here. Here we go. I'm going to pour the palladium, or the dimethylbloxine, right into our solution here that contains our palladium. Here we go. Let's put the stir bar right in there too. Just let this stir. we'll let this react. We've got our solution back here. Heat turned off, allowing it to settle, allowing it to cool. Now what we're going to do is we're going to turn the stirrer off here. I'm going to add our sample right into this main batch here. Rinse it out. And then we'll let this settle. And we'll get the palladium out of here into a filter. And then we'll proceed with a refining on the palladium. We'll use some SMB to precipitate the gold out of this solution back here. And then we'll proceed with the refining of the platinum out of this solution in part 3. This will conclude part 2 of the stock pot refining series. Thanks for watching.